Okay, for tonight's homework, I'm going to have you finish these problems on this paper, on this handout, and then I'm going to have you do them again into your composition notebook. So this first one here is graphing a system of inequalities. This first one here is ready to go. This is solved for y, ready to go. The second one, the first one is not solve for y. So here's the math to solve that top one for y, to get y by itself so I could graph it. So the first step, get rid of this 2x, which is positive, so I'm going to do the opposite, subtract 2x on both sides. Make sure to bring down the negative with the y. Inequality comes straight down, more than or equal to. Negative 2x plus 3 cannot combine these. Do not subtract unlike terms. Try to write it in slope-intercept form with the x first and the y number second. So now, this is still not ready to graph. That negative needs to get out of there. That negative is a negative 1 times that y in disguise. So the opposite of timesing by negative 1 is dividing both sides by negative 1. Dividing by a negative will flip this inequality from more than to the less than or equal to direction. This negative 1 will divide into both terms here. We'll divide into that negative 2x and divide into that 3. So here we go. When I divide both sides by negative 1, the inequality will switch. These negative 1s will cancel away, and that will be y less than or equal to positive 2x minus 3. Because remember, negative 2 divided by negative 1 is positive 2. 3 divided by its own little negative 1 gives me negative 3. So that is 2x minus 3. Now, I'm going to graph both inequalities and see where the shading areas intersect. So the first one here, start at positive 2 on the y-axis. Look at the number in front of x to get my rise over run. So from that 2, every time I go over 2 boxes for my run, I'm going down 1 box for my rise. So positive 2, over 2, down 1, over 2, down 1. Because the inequality is a plane inequality, that will be an incomplete line, incomplete inequality, dotted line. Here I'm showing you again where I got that rise and run from that number in front of x. Here's why I have a dotted line, because it's a plane inequality. Because it is y is less than, looks like an L, less than, I'm going to shade a little bit below. Do not shade the whole thing until you find out exactly where the shaded areas intersect. So I'm just going to shade down a little bit here. The other inequality has a y-intercept of negative 3. So negative 3 on the y-axis. Looking at that number in front of x, that is 2 over 1. So every time I go over 1 from that negative 3, I go up 2. Over 1, up 2. If this is a set of inequalities, don't worry if they don't meet at a nice neat point. You're not looking for that point. You're looking for where the shaded areas overlap. If this was a set of equations, you would be looking for that point. But this is a set of inequalities. The inequality is less than, so I will shade a little bit below that blue line there. So shading below. And now I could see of these 4 areas, only this area has the shaded areas overlap. There's nothing up here. Only half shaded right here. Only half. This is the 1/4 of my graph where the shaded areas overlap. So once I identify that, I'm going to fill and shade that section in nice and neat, best I can. All right, number 2. Solving this system of equations equals here using substitution methods. So I'm looking for a point that will satisfy both equations. The first step is to solve one of these for x or y. Of both of these, the easiest step is solving that second one for x. all I have to do is add y to both sides. The benefit of that is this is all positive. Any other of these variables you'd be solving for would give you a negative, and that's tough. So one step right here, adding y, gets x by itself. That x shows me where in the other equation I'm going to substitute right here. This y plus 8 shows me what I'm taking and substituting right there. So the first step, solve one of the equations for x or y. Second step, plug it in. So you can see that 2's still there, but where that x used to be, I'm putting in y plus 8. I still have that 2y, I still have that 4. This is definitely distribute. I'm going to times that 2 times the y and times 2 times 8. This will give me 2y plus 16. 2 times y is 2y, 2 times 8 is 16. Bring down the 2y, the equal, and the 4. Combine these two y's to give you 4y. So 2y plus 2y is 4y. Bring down the plus 16 and the equal 4. Here the first step is to subtract both sides by 16, minus 16. Those will cancel away. 4 minus 16 is negative 12. 4y equal to negative 12. I'm going to divide both sides by 4 because this is 4 times y. The opposite is dividing by 4. That gives me half of my answer, y equals negative 3. Remember, I am not done. That is only half of my coordinate, half of my answer. I need both x and y when I'm solving a system. So negative 3, half of it. So now my third step is to take that negative 3 and I'm going to plug it in right here to solve for x. I could have plugged that in here or here, but that would make my life more difficult. This is the easiest one of all. All of these are equivalent, so I could plug it into either one. So where y used to be, I'm going to replace that with negative 3. So right there. So that gives me x equals, and where again that y used to be, I plug in negative 3. I still have that plus 8. That gives me x equals 5. That is the solution point, 5, negative 3. I'm just going to show you the check just to show you what happens. So if I take that point x and y, x is 5, y is negative 3, and plug it into both equations, it should work. So where that x used to be, I plug in 5. Where that y used to be, I plug in negative 3. That gives me 10 minus 6 equal to 4. 4 equals 4. That is a true statement. Next, I'm going to plug in for x, plug in 5. I still have that minus. Where y is, I plug in negative 3. That is a double negative. That gives me 5 plus 3, which is 8. That is another true statement. All right, parallel line. Parallel line has the same slope. The slope of the line they want it parallel to is this one, has a slope of 2. So my parallel line will also have a slope of 2 or 2 over 1. I want you to go through this separate point. So I go to the point 2, 1, plot it right here. And from that point, I use that slope over 1, up 2, over 1, up 2. Stair step both directions. Draw my line, see where it crosses the y-axis. I'm going to have you write the equation of this new parallel line. That equation is y equals 2x, same slope, but a different y-intercept, minus 3. So that new line is y equals 2x minus 3. It has the same slope with a different y-intercept. So here in red, I'm going to graph that original line. So that line is y equals 2x plus 1. So 1 on the y-axis over 1 up 2 over 1 up 2. That is the line y equals 2x plus 1, and you can see these are both parallel but have different y-intercepts. Okay, next problem, number 4. Perpendicular lines. Perpendicular lines do not have the same slope. They have negative reciprocal slope. So negative reciprocal is taking that slope of 2, making it a fraction, and flipping it and making it the opposite. So if I take 2 over 1 and I flip it, it becomes 1 over 2, and I have to make that the opposite 2. So the opposite of positive 2 over 1 is negative. So that perpendicular line will have a slope of negative 1 over 2. So I go to the point negative 2, 3, and from there I go a run of 2 and down 1 for my rise. Run of 2, down 1. Run of 2, down 1. Be able to stair step both directions. I'm going to draw that line and see where it crosses the y-axis so I could write my line in slope-intercept form. So that line is y equals negative 1/2 x plus 2. That is the y-intercept. That is the line perpendicular to this. I'm just going to graph this line for you so you can see what it looks like. So 1 over 1 up 2 over 1 up 2. Draw my line, and you can see these lines cross each other at a 90-degree angle, a right angle. Perpendicular lines. Alright, next problems. For a reflection, I'm going to reflect it over this x-axis. Reflection means you go equal distance straight across the line of reflection. So A is 2 points above. The new A for my image is going to be 2 points or 2 boxes below. The new B, 3 boxes below the line of reflection. The new reflected point, 3 boxes above. So that new A is 2 boxes below that reflection line. That new B is 3 boxes above. I know that looks kind of weird, but that's how you reflect through an object through itself. It looks like a little X right there. So A prime 2 below, B prime 3 above. That is the reflection. This is going to have the way they translate it on the test. They're going to show you x plus 2, y minus 3. From that, you see that you're going 2 boxes to the right. Minus 3 shows you're going down 3 boxes. So here I go. The new A, 2 boxes to the right, 3 boxes down. That's where A prime is going to be, A for the image. From B, 2 boxes to the right, 3 down. That is the new B, B prime. So A, B, this is my pre-image. A prime, B prime, this is my image. You can see I went over 2, down 3. Alright, I hope this video helps. I'll be in my room every day for help. Good luck.